So for question 2, we're given a slightly more traditional game tree, at least more traditional than question 1. And really what it's asking us is to display a 2-player game between Alice and Bob. And Alice is a maximizer and is represented, her actions are represented by these triangle nodes. So this is Alice. And Bob is also a maximizer, and his nodes are represented by these ovals. But I guess the real main issue with this problem is that Alice believes that Bob is a minimizer with probability 0.5 and a maximizer with probability 0.5. And Bob knows that Alice is aware of this, and Alice just has this misconception of how Bob is playing. And from this, we want to figure out the values at each of the nodes right here, which consist of a tuple, like xa, comma xb, where xa is just going to be Alice's expectation of the outcome at that node, whereas xb is Bob's expectation of the outcome at that node. And just for clarity, we also tie break, choosing the left branch. So given all this, let's look at an example where we have this kind of subtree-ish thing right here. So this Bob's oval node. And let's just see how they got 5, 9. Well, for 5, this is Alice's expectation of the outcome. And Alice expects Bob to choose between 1 and 9 with equal probability because she believes that he's a maximizer or minimizer with equal probability, and 1 and 9 are both max and min, or min and max respectively. So in this case, if you take the expected value of 1 and 9, you get 5, assuming they both have a probability of 0.5. Now for the rightmost value here, 9, well, this is Bob's expected outcome of his utility at that node. And Bob himself knows that he's going to choose the maximum value because he is a maximizer at heart. So in this case, he's going to choose the maximum value, and then his value that he propagates up will be 9, which is the maximum of 1 and 9. All right, cool. So now that we have this understanding of how the nodes kind of calculate value, we can try to see if we can figure out the tuples B, E, and D. So that's part A and part B. So for tuple B, we know that the left value of Alice's node is going to be the maximum of the left values of its children nodes. Why? Because the left values of each node consist of the outcome that Alice expects it to be. And so if Alice is a maximizer, she's just going to choose the maximum of the outcomes that she thinks will occur. So for BA, she knows that this value is 4, and the value that she believes is in this oval node is 5, because that's what she thought that Bob would choose based on her analysis of how Bob acts. Therefore, BA is going to be the maximum of 4 and 5, which is just 5. Now, Bob, on the other hand, knows exactly how Alice is going to play. Therefore, he knows that Alice will choose the node that corresponds to her interpretation of the highest value that she would get, which means that Bob knows that the actual value that Alice would propagate up is 9. And since he knows that Alice will choose from this node regardless, the value that gets propagated up to BB, which is this value right here, is just going to be the value associated with the maximum left value of either node. So in this case, because 9 is the actual value at this node and Bob actually knows what it was, 9 is the value that gets propagated up in Bob's expected outcome, because Bob knows what Alice doesn't in this case, which is that he's playing properly, but Alice doesn't know that he is. Okay, we can do a little simpler thing for EA and EB, where since right here we're not propagating up from any other player node, we're just propagating from leaf nodes. We can just use what we know from the problem description about how each Alice and Bob play the game. So Alice, for one, is always going to expect Bob, right, because this is Bob's node, to choose between the maximum and the minimum with expected probability. So this is 13 times 1/2 plus 1 times 1/2, which is just 7. So Alice believes that the value at this node is 7, whereas Bob is just going to choose the maximum. So Bob is just going to choose 13, which is the maximum leaf node. All right. Now for this last part in part B, we're asked to determine the values of the tuple dA and dB. So in this case, we know that dA dB is Bob's node once again right here. And we can just look at how Bob's nodes act in order to come up with a general expression in terms of x. And right here, dA, recall that dA is supposed to be what Alice believes to be the expected value of the minimizing and maximizer values. So since we have an expected value, we know that between these two values, one of them has to be a minimum and one of them has to be a maximum. So therefore, we can just take 4 plus half of x, right? Because that's just like dividing their odds by equal probability and then summing them up, or dividing their values by the same amount and then summing them together to get the expected value. Whereas on the other hand, dB is going to be the maximum of either a and x because that's what Bob chooses because he's a maximum. All right, great. So let's move on to the next parts. So parts C and D ask us to essentially compute some range for the values of the tuple CA and CB. And we want to compute that range based on x, where if we set x to be less than something, we want to guarantee that CA/CB is a certain value. And if x is not in this range, then we want to say what is CA and CB in this other case. So notice CA/CB right here is a triangle node. So its tuple is going to be the same as its child that has the maximum left value, right? So in this case, it's either going to choose between EAEB or DADB. So recall that we solved for EAEB before up here. So this was 7 and 13. And we also solved for DADB, which was, 4 plus 0.5x, comma, maximum of 8, comma, x. And so if we take a look at just like the format of the question, we can pretty much just like plug in those values for what the possibilities of CA/CB should be. So we can just plug in 713, and we can plug in 4 plus 0.5x, max of 8, comma, x. But the main question here is, what is the range for which that we choose 7, comma, 13 over the other one, 4 plus 0.5x, comma, max 8, comma, x. And really, if we recall how Alice chooses nodes, we know that Alice is going to just choose the maximum between 4 plus 0.5x and 7. So therefore, in order for Alice to choose the node 7, comma 13, this inequality must hold, where 4 plus 0.5x must be less than 7, since Alice is only choosing based on the left value of the node. And in this case, if we just solve, we're going to get 0.5x less than 3, and x is less than 6. Therefore, we can just write in 6 here, and we're done. So we know that if x is between 6 and negative infinity, we will guarantee that Alice will choose the rightmost node because 7 is better. Otherwise, we have this value of 4 plus 0.5x, comma, max 8, comma, x. And the reason it's like this equality thing right here, so if they're both 7, right, it actually works. It's because we had that tie-breaking thing where we choose the leftmost node in case of a tie. And so then we will choose the dA, comma, dB node to propagate up in case of ties. Okay, for part D, we're asked something similar, except in this case, we have AA and AB, which is actually Bob's node at the top. So since it's a round node, right, we know that Bob is always going to choose the maximum of its children. And Alice believes that Bob is going to choose the expected value of its children. So in this case, if we consider the possibilities, let's suppose that x is once again less than 6, because we determined that range previously. Well, if x is less than 6, we know that the children of these two nodes right here, BA, BB, if x is less than 6, BA, comma, BB is equal to what we saw at the top, which was 5, comma, 9. And CA, comma, CB is going to be 7 comma 13, which is what we figured out. So from here, it's more straightforward to calculate the oval node, right? Because once again, Bob is just going to choose the maximum, which is just 13, of the right-hand nodes of the right side. So between 9 and 13, Bob is going to choose the maximum. And meanwhile, Alice is going to say, okay, we're going to take the expected value between 5 and 7, between what she believes are at those previous nodes. So the expected value of 5 and 7 is just 6. So in this case, if x is less than 6, we get these as our values. And in the other case, if x is not less than 6, then we know that the value is greater than or equal to 6. We know that the value at CACV is not 713 anymore. It's going to be this 4 plus 0.5x, comma max of 8 comma x. So let me just write that down. CACB is going to be equal to 4 plus 0.5x, comma maximum of 8 comma x. Okay. So in this case, we still know that the oval node is going to behave in the same way. So it's just going to choose the maximum between 8 comma x and 9, which means in this case, that's essentially the same as choosing between 9 and x. So we have it like this. And we know that Alice believes that Bob is choosing the expected value once again. So we know that she's going to choose the expected value between this 4 plus 0.5x and 5. So CA in this case is going to be 4 times 1/2 plus 4 plus 0.5x times 1/2 is going to be 2 plus 2 plus 0.25x, and that's just going to be equal to 4, oh no, 2, 4, okay, 4 plus 0.25x. Oh, my bad. I just realized I put 4 instead of 5, so this should be 5, right? Since we took the value of BA directly. So this should be 5 times 1/2 plus 4 plus 0.5x times 1/2. So in this case, this shouldn't be 2, this should be 2.5, and this should be 4.5. So the answer right here in this node should be 4.5 plus 0.25x. Yeah, the box is kind of small, but you get the idea. So the last part, part E, is essentially saying, okay, can we prune any of these values? And the quick answer is basically no, because most of these nodes are determining an average of the minimum and max across all children nodes that are seen. And we can't really get that unless we've explored all of the children of any given node at any given time. So just from that quick analysis, we can say that no pruning can technically be done for Alice, right? Because Alice is always looking at the different possibilities, because Alice knows something, or Alice thinks she knows that Bob is a minimizer and maximizer with different expected value, but Bob knows something different, where Bob knows he's just a maximizer. And because we have to consider Alice's expected value status, I guess, we can't really prune any of the nodes that are connected in that case. Therefore, the answer here is not possible. All right, and that's all for exam prep number 3. Thanks so much for watching, and see y'all next time.